Chris here from Griffiths Heating on this lovely sunny morning. Look at that, spring is in the air, summer's on its way. What we're doing today, or for the past few days, is we're on a bit of an emergency job. Extension getting built on a house, and the boiler broke down, and we needed to put the new boiler in, because what was happening, that wall's coming down, new boiler going in, part of the building works, but obviously that's now fluing into an extension, so it's had to be disconnected, and we've had to emergency fit an Ideal Logic, not my boiler of choice, but all I could get at short notice at the minute. A lot of this is temporary because it's just kind of just had to make it work for now. Such as the condense, don't really know what's happening with the drain, so it's just dripping onto the floor outside. And again with the condense, not sure on the wall finish, so that's going to have to be adjusted to wherever, whenever. Pipe this one in MLCP, our pipe system of choice at the minute. Half the price of copper, twice as quick to fit. All this is going to get lagged, obviously. Well, the flow is going to get lagged, but we're going to leave the return unlagged, so we shed as much temperature as we can as the return water gets to the boiler, just to boost that condensing efficiency on the boiler. We're running it on a weather comp system. If you fit in an Ideal Logic, there's really no reason not to fit a weather compensator. Obviously this again is just temporary. It's going to run externally once the Sparky puts a cable in for us. It's just running on and off, time on a hive, and the boiler modulation is controlled by the weather comp sensor. You then set the weather comp curve on here, and it helps that boiler run a little bit more efficiently, or a lot more efficiently, because it adjusts the output temperature in line with the external temperature. So yeah, basic run of the ground. We've got a cloakroom here, sink, toilet, shower. Utility room here, wall there, there's a rad going there. And this is part of the kitchen, it's all getting knocked through. Two walls coming down, big kitchen diner, and we've got an upstairs. And also, as part of the work, we're converting this system to a DT35 system. And what that means, don't confuse it with the DT Floam Return, it's the room delta. If you look at your Stelrad catalogue, most of the radiators will be designed to operate at DT50, which is a 50-degree difference between the surface temperature of the rad and the room, or the mean water temperature and the room. So we're running this at a 65-45 design temperature, which gives a 35-degree room delta, because our mean water temperature in the radiator will be 55, with the room temperature 20, so that's 35. So this is the upstairs of the extension. We've got a bedroom here. That's getting a knock through there to extend the size of the bedroom through there, so it's a double-sized bedroom. This is going to be an office, and here is a bathroom, 1700 tray there, toilet basin, easy as that. When we size the radiators, we've got to up the size of them by about at least half, just so we've got the right emitter size. So one thing that I come across a lot on jobs is when the property's first fixed without any reference point to do the pipes on the wall, the pipes are often too tight to the wall and they don't enter the rad valve straight, and they're crooked, or they're halfway in the skirting board. Doesn't take much effort to figure out what you've got to do. We're having a K2 radiator here, so we have 30mm for the dot and dab, and if you look at the Stelrad data on the radiators, from the surface of the wall to the centre of the radiator valve point is 72mm, which gives us a total distance from the wall of 102. It looks too much. You'd think to all the world you first fix that, you think fucking hell, the pipe's going to be in the middle of the room by the time it goes on, but no, by the time you got your dot and dab your skirt and your rad, that's going to be bang on. And obviously plus 95 for the valves, so 695, 102mm off the wall for a K2, and yeah, that should work out perfect. So I mentioned briefly in the video there about radiator size, but didn't go into it in any further detail. It's quite simple, but it's quite complicated at the same time how you calculate the sizes of radiators. So the first thing you need to do is a full heat loss on the building. But let's take the front bedroom of that extension you just saw, and let's just say we need a radiator of 500 watts to heat that to 20 degrees on the coldest day of the year. So what we need to do, first thing we need to do is decide the temperature we're going to run our heating at. And I said previously we're going to run it at 65-45. So that's 65 flow, 45 degree return. And with those numbers there, we can work out what's called the mean water temperature, which is the average surface temperature of your radiator. So to do that, we do 65 plus 45, flow plus return, divided by 2 equals 55 degrees. So if you're running a 65 degree flow, the surface of your rad on average is going to be 55 degrees. And then once we know that number, we can then move on to our room delta, which is the difference between the design room temperature and your mean water temperature. So mean water temperature, take away 20 degrees, which is the room temperature, gives us a room delta of 35 degrees. Now, when you look at the radiator catalogue, all the outputs will be measured in DT50, which is 75 flow, 75 flow, 65 return. So if we pick a radiator that outputs 500 watts at DT50, when we run it at DT35, putting less energy through it, it's going to kick out literally half that watt. So you put your 500 watt rad in and it will only be kicking out 250, 300 watts, and the room won't get to temperature. So what you have to do is apply a correction factor of delta 35. CIBSE published tables for these, and you need to multiply your radiator size by 1.66 for DT35. So 500 times 1.66 is 830 watts. So you need to look in your DT50 catalogue for a radiator that outputs 830 watts, and then when you put your DT35 energy through it, it will give you 500 watts. Simple as that.